What's going on, guys? It is Thursday, May 7th. Hopefully, yesterday's catch-up day helped out and got everybody caught up. But most of your grades are in, okay? Your summatives are in. So take a look at those, and if anyone wants to retake it, that's fine. I could set that up for you. Just email me, all right? But just know we are going to move on to Chapter 11. As you can see, we're starting with 11.3. All right, so just kind of know that we will be kind of skipping some of the sections for the rest of the year, just to focus on the most important things to get us through virtual learning and for you guys to be prepared for geometry. All right, now I'm going to be very, very honest with you. Chapter 11 in general is difficult. All right, it is difficult. So it's going to be difficult for me to teach virtually, and it might be difficult for you to learn virtually. So I'll be honest with you. All right. So we need your full focus here. Okay, and we are going to split up some of the lessons. Today's lesson especially, we will just be focusing on one part today, and then we'll talk about part two tomorrow. All right, so let's start to read here and try and make sense of what we are going to be doing today. All right, so first things first, we are working with rational expressions, and we are going to be simplifying them. All right, so let's understand what that is in the first place. A rational expression is an expression that can be written as a fraction whose numerator and denominator are polynomials. Values that make the denominator of the expression 0 are called excluded values. Now let's make sense of that quick. If we have a 0 in our denominator, we try and divide by 0, that's something called undefined in mathematics. All right. So they're saying that the values that would make the denominator equal 0 are going to be called excluded values. Values that we don't want, because they would again make our math be undefined. Okay, so that's one thing to know. Now, simplifying rational expressions, our key idea today. A rational expression is in simplest form when the numerator and denominator have no common factors except one. To simplify a rational expression, factor the numerator and denominator and divide out any common factors. So I'm going to tell you now, today's examples that we're doing will already be factored for you. Okay, so we're going to focus today on just simplifying these rational expressions and then identifying the excluded values. Okay, so algebraically, let's take a look at an example they give us. They're saying, here's a way we can look at this. Let A, B, and C be representing polynomials where B and C are not 0. And we can see that we have A times C on the top and B times C on the bottom. And those C's, those common factors, we could simplify by canceling them out and be left with just A over B. All right, so that's an algebraic way of looking at it. Now here, they give us an actual example with numbers included. All right, on the top, we have 2 times x plus 1, and on the bottom, we have 5 times x plus 1. These are already factored for us, okay? Tomorrow's lesson, part 2, we'll have to factor as well, so it gets harder. All right, but what they're showing us is we have x plus 1 on the top and on the bottom. We can cancel those out and be left with just 2 over 5. And then here, where it says x cannot equal -1, they're going back and talking about those excluded values. If we plugged -1 in for x on the bottom, it would make the expression equal 0, and it would make the denominator equal 0. So when they write x cannot equal -1, they're identifying an excluded value for this example. All right, so just to show you our learning target, it is going to be that we can simplify rational expressions and we can identify excluded values. Okay, those are the two things we are focusing on today. So we're going to start with the most basic types of examples we possibly can to make sense of this. All right, so here we go. Getting into example 1. So let's take a look at what the book does. They basically show the prime factorization of these two expressions, these two polynomials, okay? So they're taking 12 and breaking it into its prime factorization of 2 times 2 times 3. They're doing the same thing with 2x squared. Prime factorization would be 2 times x times x. Eventually, you'll probably get good enough at this where you don't even have to use this method where you're dividing or where you're writing out the prime factorization. You'll be able to just divide, okay? eventually and simplify in your head probably. So again, it is nice to visualize this though to start. We can divide out 2's from the top and bottom, all right? And we would be left with 6 on the top, the 2 times 3 that's left, and then x squared on the bottom, the x times x that is left, all right? So the excluded value, we want to take or find that excluded value before we simplify, okay? So when we look back at this original expression, what is the value or values? As you can see, it says state the excluded values. So sometimes there's more than one. In this case, what is the value that we could plug in for x that would make the denominator 0? It's just 0, okay? Because 0 squared would be 0 times 2 would be 0. That makes the denominator 0. All right. Now, real quick, when we look at this next example, I'm going to point something out to you. We want to picture any expression that has a plus or minus involved or included in it as if it were in parentheses if it doesn't show us parentheses. Okay, so this n plus 8 is really in parentheses. Now, something else we want to remember, we can't do anything with this unless it said the exact same thing on the top and bottom. All right, so what I want to show you is this. If it said, I'm going to make up my own example here. If it said n plus 8 on the top and n plus 8 on the bottom, right? And let's say there was like a 2 here and there was a 3 here on the bottom. All right, what we could do now, because it says the exact same thing, we have the exact same expression in parentheses, is we could cancel these to simplify and be left with 2/3 as our answer. Okay, since we don't have an n plus 8 on the top and we don't have an n that's on the outside of the parentheses in the bottom, this expression is already simplified for b. Okay, there's nothing we can do with it. All right, so remember though, what's the excluded value in this problem, which we want to find right away too. So what makes the denominator 0? -8 would do that. All right, -8 would be the excluded value here because -8 plus 8 makes the denominator 0. All right, now problem C. Problem C, we're just going to continue with what the book does. They write it out in prime factorization. Okay, so 3y squared is really 3 times y, and then 6y, they're rewriting as 2 times 3 times y. And then the y minus 7 is kind of its own polynomial, all right, its own expression. Now, because remember what I said, because there's no y minus 7 on the top in parentheses, we can't do anything with this, okay? We can't touch this. So what we can do is get rid of the 3's and get rid of one of the y's. So what are we left with on the top? We are left with just one y on the top, and we're still left with our 2 on the bottom and our y minus 7 on the bottom, all right? Now, in this case, there were 2 excluded values. If we look at the original expression, what would make 6y equal 0? 0 would. What would make y minus 7 equal 0? 7 would. So this problem has 2 excluded values. Okay, the excluded values are 0 and 7. All right. So there's your first example. Hopefully that made sense. Let me show you a couple of extra examples. Okay, and let me just explain to you what I would do in my head. All right, to simplify. I will show in a minute if we write out the prime factorization, but what I'm thinking here, if I'm looking at problem A, is I'm going to look at the coefficients first, okay? So I'm going to look at the coefficients first. So 21 and 7. 21 divided by 7 is 3, okay? So I know that my top, I'm writing my answer. Again, 21 over 7 is really 3 over 1. So I know on the top I'd have a 3. All right, now I look at my variables. I have one x on the top and I have 2 x's on the bottom. Where are there more x's? There are more in the denominator. And there's more by 1. There's one more, okay? So what we could do here is we could cancel out the x on the top and one of the x's on the bottom to be left with only one x on the bottom. All right, my excluded value, remember we look back at the original expression, it would just be 0. Okay, so this is my simplified answer. It would be 3 over x, and I just do my excluded value would be 0 in this case. Okay, so these are the 2 parts to your answer that you need. All right, now let's take a look at how the book would do this quick to make sense of this. All right, hopefully the excluded value makes sense here. It's pretty easy in this one, but here's what the book would do. They would take the prime factorization of 21, which would be 7 times 3, and then times the x. The prime factorization of 7, 7's already a prime number. Okay, so 7, let's write it as a fraction. 7 times 1, which we don't have to show, and then how many x's we have? 2. Okay, so here's another way to look at it. This is what the book would show, is we have 7's on the top and bottom that we could cancel, and then we have at least one x on the top and bottom that we could cancel, and here's what we're left with. Okay, is our 3 over x, which is exactly what I had before. All right, and our excluded value is 0. Okay, problem B. Hopefully you remember what I told you. Anytime you see an expression that has a plus or a minus sign, we have to picture that expression as if it were in parentheses. And we can't do anything. We can't simplify any of those expressions unless it says the exact same thing on the top and bottom. Since the top does not have a 10 minus c, I can't do anything with this. Okay, since there's no 3 on the outside of parentheses here, I can't do anything with this. So problem B, as we can see, it says simplify if possible. Problem B is already simplified. Okay, so I'm simply going to look now for an excluded value. And in this case, my excluded value would be, what makes the denominator 0? 10 minus what? 10. 10 would be our excluded value in this case. All right. Now, the last one. All right, the last one. So 2w to the third and 8w squared. See how I have this w plus 5 in parentheses, and I don't have one up here? I have no w plus 5 up here. I already know that I can't do anything with this, okay? I can't simplify this at all. I'm going to focus on the 2w to the third over the 8w to the second, all right? And again, here's how I do this in my head. I'm going to look at my coefficients here, the 2 and the 8, and I know that 2 over 8 is really 1/4. So I'm going to start with that. I'm just going to make a fraction, and I'm going to say 1/4. And now I'm going to focus on the w's. So I have 3 w's on the top, and I have 2 on the bottom. I have more on the top. And how many more? I have 1 more w on the top. Okay? So now let's think about, do I really need this 1? Nope. So I'm going to get rid of it. Okay, so I'm left with w on the top, and then my 4 on the bottom, but then remember my w plus 5. Okay, sorry, this is difficult. So I'd have w plus 5 on the bottom. So this would be my final answer, my simplified answer. Now my excluded values this time, I have 2. Let's go back and look at the original. What would make 8w squared equal 0? A 0 would. And then what would make w plus 5 0? -5. Okay, so simplified expression and excluded values. All right, so both parts of our answer are here. Okay, so hopefully this makes sense. It's difficult to teach online, but hopefully this makes sense. Let's see. We can have you guys just give these a shot. All right, so what I want you to do right now is pause your video and try these, and when you come back, answers will be up and we can discuss them. Okay, so here are our answers. In number 1, here's my thought process. Ready? 5 over 2. That cannot be simplified. Okay, we can make it 2.5, sure, but they're just having you See if there's any greatest common factors, okay, between 5 and 2. There's not. All right. So 5 over 2 does not change. Now the y to the third and the y to the second, there's one more y on the top, right? So that's why I'm left with one more y on the top. So 5y over 2 is our simplified answer, and 0 would be our excluded value, okay? Number 2, here's what I always look at right away. I see this x plus 1, right? And I don't see 1 down here. I already know I'm not going to do anything with it, and it's still going to be there when I write my simplified answer, all right? Now let's focus on these polynomials, the 8x and the 12x squared. I think this 8 over 12 is really 2/3. So here's where the 2/3 comes in, okay? And I look at the x's, and there's an extra x on the bottom by 1. There's one more on the bottom, okay? Which is why my denominator is 3x. So I'm left with 2 times x plus 1 on the top over 3 times x, okay? And once again, my excluded value, I go back to the original, was just 0, all right? Now let's look at number 3. Let's remember, this should be viewed as if it were in parentheses, okay? So because it says something different on the bottom, I have m plus 1, and then I have an m plus 3 on the bottom in parentheses, but those are not the same exact thing. In order for me to cancel anything like this, they have to say the exact same thing, all right? Since they don't, I can't simplify anything in the parentheses. This m doesn't have an m on the outside up here for me to do anything with or cancel out. So this is already simplified, all right? So this expression is in simplest form. Now the excluded values, what would make this m equal 0? 0 would. And what would this make this expression with an m equal 0? -3 would, okay? All right, so that's it. We're just going to focus on, again, simplifying expressions that are already factored. All right, so these problems, you're going to go into your big ideas assignments, all right, and you're going to work on 11.3 practice, part 1. Okay, there's 8 questions, and you're just going to, again, be focusing on simplifying expressions that are already factored today. And then we'll get into something a little bit harder where we have to factor ourselves tomorrow, all right? But again, in order for us to move on in general to tomorrow's lesson, we got to be able to simplify and identify excluded values. So that's what you're going to work on today. If you have questions, email me or ask in the discussion thread. Otherwise, I'll talk to you guys tomorrow.